Let's look into the first exercise of chapter Probability, exercise 14.1. Complete the following sentences. First question: probability of an event E plus probability of an event not E. According to the formula, P of E plus P of E bar is equal to 1, which is probability of an event E plus probability of an event not E is equal to 1. Therefore, the answer is 1. Second one, the probability of an event that cannot happen is dash. Such an event are called dash. So the probability of an event that cannot be possible will definitely be 0. Therefore, the events which has the probability zeros are called as impossible events. The probability of an event that is certain to happen is dash. Such an event is called dash. So the probability of which we are sure of the outcome is always equal to 1, and such events are called as sure or certain events. The sum of the probabilities of all the elementary events of an experiment is equal to dash. To understand this question, let's look into an example. Let us consider a basket containing 4 different colors of balls. Now, the sum of all the elementary elements will be is equal to the sum of favorable outcome by all possible outcome. The favorable outcome of each color will be 1 and the total possible outcome will be 4. Therefore, the sum of these will be 4 by 4, which is equal to 1. Next question is, the probability of an event is greater than or equal to dash and less than or equal to dash. Now, according to the formula, P of E, that is the probability of an event, is less than or equal to 1 and greater than or equal to 0. The answers will be 0 and 1 respectively. Second question. Which of the following experiments are equally likely? Explain. A driver attempts to start a car. The car starts or not. This event totally depends upon the ability of the driver, whether the driver is fit to drive the car or the environmental factor which is hindering the car to start or stop. Therefore, this event does not have equally likely outcomes. Next question. A player attempts to shoot a basketball. He or she shoots or misses the shot. This event too depends upon the ability of a player, whether to hit the ball or to lose the ball. Therefore, this event also does not have equally likely outcomes. Next question. A trial is made to start answering a true-false question. The answer is right or wrong. There are 2 chances in this event. The first one is either the answer will be true or the answer will be false. The probability of answer to be true is 1 by 2 and the probability of answer to be false is 1 by 2. Here both the outcomes are of same probability. Hence this event have equally likely outcomes. This event also have 2 chances, either the baby be born girl or the baby be born as a boy. Since the outcomes have equal probability, the events have equally likely outcomes. Next question. Why is tossing a coin considered to be a fair way of deciding which team should get the ball at the beginning of a football game? This event also consists of 2 chances, which is either by tossing a coin we get a head or a tail. So the probability of getting a tail is equal to 1 by 2, and the probability of getting a head out of tail and head is 1 by 2. Since both the probabilities are equal, this event has equally likely outcomes. Hence, it is fair to toss a coin during the football match. Fourth question. Which of the following cannot be the probability of an event? First one, 2 by 3. First of all, let us consider the formula P of E, that is the probability of an event, is greater than 0 or less than 1. 2 by 3 when divided we get 0.66. This is how I got 0.66. 0 point, adding 0 at the end, 3 6 are 18, minus 2, again adding 0 at the end, 3 6 are 18, and the remainder is 2 again. Therefore, P of E means probability of this event is equal to 0.66, which is less than 1. Therefore, 2 by 3 can be a probability of an event. Next question, minus 1.5. Minus 1.5 is the probability of event here, which is less than 0. So according to the formula, P of E should not be less than 0. Therefore, minus 1.5 cannot be the probability of an event. Next question is 15%. 15% can be written as 15 by 100. When we divide 15 by 100, the answer will be 0.15. That is adding 0 at the end and 0 point at the quotient. We get 100 ones are 100 minus 50. Again adding 0 at the end of 50, we get 100 fives are 500 and remainder will be 0. Hence 15 by 100 is equal to 0.15, which is less than 1 and greater than 0. Therefore, 0.15 can be the probability of an event. The last question is, here 0.7 is greater than 0 and is less than 1. Therefore, 0.7 can be a probability of an event.